Hello and welcome to another tutorial. We're going to continue looking at the relational operators, which provide some sort of logical comparison, for example, equality. And we know that this operator basically for object types, it compares the references. In order to compare objects in a logical sense, we have to overload the equals method from the object class. So let's go ahead and create a new class called relational operators, and we're going to have a main method, and here let's create a new method, public static void test1, and I'm going in the main, I'm going to run test1. So what are we going to do here? We want to look at the equals, and so let's create a class. I'm going to create an inner class. So inner class, and let's say, or I can put it outside, that's fine, but let's limit the scope of this inner class to the outer class. So public class, let's call this wrapper for a number. Let's say I want to have a wrapper for a particular integer number. So int x, and public wrapper, and then int x, and then this dot x equals x. So basically what I'm doing, I'm just wrapping a integer into a class. All right. And then note that right now this is a public class. We could have also private class. And for inner classes, you can use the name private, but if a class is not inside the scope of another class, you cannot use the private keyword, right? So for now, let's just keep this public, that's fine. And we can also use, don't use anything. We can just use class, and then the scope is limited to the package, right? And let's see if we can also use the protected keyword here. We can also do that, which means any class that inherits from this relational operators class can access to this. And note that this is not a static inner class, and that means that it can have access to the state of the outer object. Now we see in this example, basically I'm not going to use any state, any parameter that is associated with the state of this outer class inside the inner class, but that's the whole meaning of not having a static inner class versus a static inner class. So this is a non-static inner class, which means it can have access to the state of the outer class, any instance of the outer class, right? All right, so what are we going to do? And one thing here is that if this inner class is not a static, I cannot directly initialize it because, or I cannot directly access this type. I have to create a type of this first. So let's say var ro1 is a new relational operator. All right, so I create one of these, and then ro1.new basically and then we say wrapper, and then 5. So var w1 equals this. So this is how you initialize or create a non-static nested inner class, and that's a little bit messy because non-static inner class means it has to be associated with the state of the object. And actually behind the scenes in the constructor, the Java compiler actually passes a pointer, this pointer of the outer class, as the first parameter. So in the bytecode, this constructor takes as actually 2 parameters: this pointer for the outer class, and then plus this integer x. So if we look at the bytecode, so let's see, relational operators, open with class file viewer, and let's look at the compiler here. So test1, this is our constructor of the outer class, and then this is our main. We have an inner class. All right, and then nest members wrapper. So we know that inner classes are differentiated with a $sign, and then so inner class we have this outer class dollar inner class name, outer class info, and then relation inner class wrapper access flag 0, and then nested members. All right, and then so here is where I'm creating a basically wrapper class. This is where I call new on the instance of this object, and what this translates into is this line of code: invoke a special, which means call the constructor of a class. Which one? It's the wrapper class, which is inner class. But look at the signature of the constructor of this wrapper class. The int is the second parameter, but a reference to the relational operators type is the first parameter, and that's the reference that is basically passed to the constructor, right? So in the bytecode, there is actually two parameters passed to the constructor. That's the reason is that every class has to be compiled to a separate class file. So this inner class, it has to be able to access the outer class, because it's not a static class, so it might use the state of the outer class. That's why you have to pass a reference or a pointer this to the outer class when you create the bytecode for this particular class. So that's one of the things that is good to know. And so going back here, so the point here is that so this is how we create this, and then let's say I want to have two of these numbers. So so num1 here, and then num2 10, right? The question is, how do we compare this? Because right now these are just wrappers, so these should act like integers. The other thing here is that because right now this inner class doesn't use any of the state of the outer class, I'm going to make it a static. That's fine, but then instead of calling the creating an instance of the outer class, we don't need that. We can directly access to the type. So we can say new wrapper, and the reason is that we are in the scope of the outer class, so we can directly access it. Or we can say relational operators dot wrapper. That's also a valid. So new relational operators dot wrapper. This is how we define the type. So the type is not exactly wrapper, it's outer class dot inner class. That's the actual type, right? So how do we compare these wrappers? So number one is comparison. Num1 equals num2. Obviously, if these are two exactly the same numbers, logically we want to when we compare them, we want to get the same value. So if I say num1 equals num2, you can probably guess that this is going to return false. That's because we are comparing references, not logical comparison. So this is not a logical comparison. So how do we do logical comparison? We do logical comparison by overriding the equals method. So right click, source, override. Basically, we're going to override implement methods, right? And it's better to just override both the equal and hash code. And whenever you override equals to give a logical operation or logical comparison, you have to also override the hash code, and you just use the utility class objects and then the hash and use the state. Remember, equals and hash, these are related to the state of an object. So if your object is designed to be stateless, you don't really need to overload these methods. But here we're just comparing the state, which is x. And remember that I mentioned before, for integer numbers you can do equal. For floating point numbers you shouldn't do exact equality, because floating points always have a limited accuracy, whereas int numbers are accurate, right? Or have exact precision. So now if I run this, it's going to return true. It's still returning false because we are still comparing the references. Num1 dot equals num2, and this is the second line here is the logical comparison. So this is a logical comparison, and that works, right? So if I say 10, obviously both of these should return false. If both of them are 10, then the first one is still returning false, because these two references or pointers pointing to different memory locations, different objects. But the second one, which is a logical operator, it returns true. And unfortunately in Java you cannot overload this equality or the comparison operator because that causes a lot of confusion. So this is the meaning of the equals method. But there is another one way for comparison. So another way of comparison is the giving your class natural ordering. And the way you tell Java or your JVM that this class has a natural ordering, you implement an interface, or basically you mark your class with an interface called comparator or comparable. Comparable interface means that these objects can be compared, right? And what this happens is that comparator is not just about equality, it's also about less than or greater than, or, right? And the contract of the comparable interface is like this. If you have obj1 greater than obj2, you want to return +1, or a positive integer number. The convention is +1. Or else, if your obj1 is less than obj2, you want to return -1 or some negative integer. Otherwise, basically the only logical way is obj1 is equal to obj2, you're going to return 0. Now the thing here is that this comparator interface is used mainly in the basically Java collection framework along with the hash code overload. So both the equals method and this comparable interface for natural ordering has to be present in your class if you want your class to be fully compatible with collection framework. Now obviously, as you probably can guess, this comparator also allows for equality, some sort of definition of equality, which you have to always be careful that it's consistent with the way you overload the equals method. So in Java we actually have two ways of giving comparison, logical comparison, right, to your class. Logical comparison to your class. You either obviously the first way is the overload or override. You're going to override the equals method, or you use the comparable interface and define what happens in which cases you return 0 or your class returns 0, right, when you do comparable. So let's go ahead and do that. We say that this class implements comparable, which is in a Java lang, and then this is a parameterized type or a generic type, and we want to compare the types, the same type as the class. This is the most way of the most common use case of this comparable. You give it the type that is exactly the name, and we're going to go and add the compare to, right? Okay, so how do we implement this? We only have one variable. Remember, compare to is also about comparing the state, right? One variable for the state of the object, which is our integer value x. So if our object 1 is greater than object 2 for a wrapper class, it just means that we compare the states or values, right? So basically, if we can switch on the values, or we can switch on the basically just have an if statement. So I'm going to say that int diff is x minus o dot x, and if diff is greater than 0, we're going to return basically +1, else we're going to return else if basically diff less than 0, we're going to return -1. Otherwise we're going to return 1. All right, so if our object is greater than the other object, which means if its value is greater than the other one, we're returning 1. Otherwise we're returning -1. Otherwise we're returning 0, which means this is the equality. obj1 equals obj2 plus 1 means obj1 is greater than obj2, and minus 1 means obj1 is less than obj2. And we can go ahead and test this. Obviously I can do a sysout num1 compared to num2, and this returns minus 1, which means num1 is less than num2. And note that this has to be symmetric, which means if num1 compared to num2 returns minus 1, num2 compared to num1 should return plus 1. This has to be maintained, otherwise things will break, because the comparison has to be symmetric. If obj1 is greater than obj2, logically it has to always be equivalent to obj2 basically less than obj1. So this has to be equivalent to obj2 is less than obj1. What this means is that if you call this compare to, it shouldn't have some sort of side effect that change the state so that another comparison returns a different value. So compare to has to always be consistent, right? Because this is eventually a binary operator. Less than, greater than, less than, or equal. These are all binary operators. Now we can test this. Where is this compare to is important? It's in the collection framework, where the order matters, right? All right, so collection framework. In the collection framework, any class that starts with tree something means it's a ordered collection that uses natural ordering of your class. So for example, if I want to create a sorted set, a set that sorts these values, sorted set is an interface, right? Sorted set, and then tree set implements the sorted set. If I open the tree set, it's implements navigable set, and navigable set it implements or extends sorted set. So basically these type hierarchies become complicated. If I open the type hierarchy for a tree set extends abstract set, extends abstract collection, and this is the class hierarchy, not the interfaces that it implements. But as you can see, abstract set already extends abstract collection, implements set, and then these are implementing navigable set, which already extends sorted set. So these have some sort of ordering, and when we have ordering, not only ordering but also comparison or relational. That's why this Compareto method comes into play. So let's say I create a var set1 is new tree set, and then it's empty, and then what we can do is say set1 add num1 and set1 add num2, right? And then let's do a sysout on set1. And basically right now it gives the list of references. So to array, we can say to array. So if we call the to a string, it just prints the string representation of the objects. That's because we didn't give a to a string to our class itself, to wrapper class. So let's override the to a string. We're going to just use x and then say wrapper x, and we actually don't need that. We're just going to basically return x as a string. All right, we can do this, or say that a string dot format %d and then x. So if I run this, this is going to give me 510. Remember, num1 was 5, num2 was 10. Even if num1 is 50, then this sorted set is going to be 1050. So each time you add these numbers, it calls the compare to, and then figures out the correct ordering, right? So we can create a new number, for example. Let's say num3 minus 100. and then add num2, set1, add num3. And then if I print the set1, you see that -100 is basically right at the beginning. So the order is preserved, and the reason is this compare to. And in order to prove that, we can do a basically sysout here. And then we can do a, for example, say that %s, or we can say compare to was called with this %d and %d, and then dot formatted what is the current x state, what is the o.x, right? So we can see what happens if I add num1. So compare to, we added num1. If I add num1, no compare to should be called. It's actually oh, we are printing this, so let's comment these out. Let's comment these to basically prints out. All right, so we just create a tree set. Any class of the collection framework that starts with tree means it's ordering your elements based on the natural ordering that comes from overriding the compare to, right? This is an override from the comparable class. Now if I add one number, it compares 50 to itself, which is very interesting. So if I don't add any number, it does that. So if we add a number, compares to itself. The reason it compares it to itself because a set elements should be unique, right? That's why it makes sure that it checks whether this number already exists or not. So it compares with itself. If I add another number, then it compares the new element, which is 10, to the previous one, which is 50. If I add the third one, then now the third one has to be compared with the two previous ones. So it's linear operation, -100 with 50, -100 with 10. So there's nothing magical here happens. It pretty much linearly compares them, because in the set the elements should be unique. That's why it compares these. And remember that this doesn't use the equals. We can actually do the equals here too. Actually, let's put this here, and then we're going to let's copy the equals here and x, and then now we are doing the obj.x. We are converting this. It's actually the other.x. I just want to show you that the equals is not called. As you can see, equals is not called for these tree sets, for these collection frameworks. It's just compare to is called. So just be careful. Even if you override the equals method, it's not actually used for the uniqueness of the sets, right? When you want to determine the elements in the set are unique or not, the compare to method or the comparison is called, which is more natural, and that's also the same way the standard library in C++, for example, is implemented. Instead of the equality operator, they use the less than operator in the standard library of C++. Same with Java. Instead of the equals method, they're using the compare to method. Just be careful about that. And this is how the comparison works. So these are relational operators that you use for basically primitive types, for example integers. But for classes, you have to implement, if you want to give natural ordering to your class, you have to use the compare to method from the comparable interface. So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.